Hi, this is Selvapriyan. Today let's see 2019 gate surveying questions from set 1. First question. The interior angles of four triangles are given below, that is for PQRS. Which of the triangles are ill conditioned and should be avoided in triangulation surveys? So we have to find the ill conditioned triangles. First of all, the triangles which are other than well conditioned triangles are ill conditioned triangles. So for well conditioned triangles, there are conditions. So the angle should not be lesser than 30 degree and should not be greater than 120 degree. So the interior angle should not be lesser than 30 degree and should not be greater than 120 degree for ill conditioned triangles. Other than these angles are ill conditioned. So for triangle P, no angle is lesser than 30 degree and no angle is greater than 120 degree. So triangle P is well conditioned triangle. And for Q, so one of the angle is lesser than 30 degree. So Q is the ill conditioned triangle. And regarding R, no problem. No angle is lesser than 30 degree and nothing is greater than 120 degree. So R is a well conditioned triangle. And regarding S, 20 degree. So this is lesser than 30 degree. So triangle S is also an ill conditioned triangle. So both the triangles Q and S. So option D is the right answer. Next question. A survey line was measured to be 285.5 meter. So a survey line is the length is 285.5 meter. The tape having a nominal length of 30 meter. So a 30-meter tape was used and its length is 285.5 meter. On checking, the true length of the tape was found to be 0.05 meter too short. So the chain is 0.05 meter too short. So a correction must be applied here. The line lay on a slope of 1 in 10. The reduced length, that is horizontal length, the reduced length of the line for plotting of survey would. So in this question, two corrections must be made. So first correction is regarding the tape length. So it is too short. So one correction must be regarding that one, that is the length of tape. And another correction is regarding slope correction. So it is laid on a slope of 1 is to 10, 1 in 10. So we have to find the horizontal length. So first of all, we have to find out the correct tape length. Uh, First of all, we correct that length regarding tape wise, and then we will do slope correction. So first correction will be standardization. It will be standardization correction. So this is for tape length. So it may be positive or negative. The correction must be maybe positive as well as negative. Uh, so in this question, it is too short. So if the chain length is if the chain or tape length is too short, it is negative correction. If it is too long, it is positive correction. In this question, it is too short, so it will be negative correction. So the correct tape length will be is equal to 30 minus 0.05 meter. So it will be 29.95 meter. So this is the actual tape length. But the designated length given is 30 meter. So now the correction is equal to designated, that is measured length, divided by designated tape length into correction. So it will be measured length is 285.5 meter and designated tape length is 30 meter. Correction is 29.95 meter minus 30 meter. So it will be minus 0.05 meter. That is negative correction. So it will be equal to minus 0.4758 meter. Minus 0.4758 meter. So this is regarding tape correction, and one more correction is that is slope correction. Slope correction is always negative. Always negative. The line is laid on a slope of 1 is to 10. Length measured was 285.5. So formula for slope correction is equal to L into 1 minus cos theta. So we have to find out the theta first. For that, we have the slope, that is tan theta is equal to 1 by 10, because it is laid in 1 in 10 ground. So tan theta equal to 1 in 10. Theta is equal to tan inverse 1 in 10. Theta is equal to 5.71. 5.71 degree. So correction is equal to 85.5 L into 1 minus cos theta. Is cos 5.71 degree. This is always negative correction. It is equal to minus 1.416. Minus 1.4. So the total correction is standardization correction plus slope correction. Both are negative. So it is minus 0.475 plus minus 1.417 equal to minus 1.892 meters. So this is the correction which you have to apply the measured line. The reduced length, that is horizontal length. This is what the horizontal length. So this is the length that we have to find out. So it is equal to correct length is 285.5 meter minus 0.8 283.6 meter 83.6 meter is given in option A 83. So in this correction, two corrections are needed. That is first one regarding tape correction, that is standardization correction, and look at the question whether it is too short or too long. If it is too long, it is positive correction, and flow correction is always negative. For this, you can also use the other formulas, that is h squared divided by 2l. So you will get the same answer in both these formulas. H squared means this height is h. So to find out this h, we have to we can find this height, that is 1 divided by 20, 1 divided by 10 to 285.5. It will be equal to 28.55 meter. 28.55 meter. With this height, you can h squared divided by 2l. You will get the correction, that is minus 1.417. The same result we will get in this formula also. The next question: the staff is placed on a benchmark of reduced length 100 meter. Mark reduced level is 100 meter. Staff is and a theodolite is placed at a horizontal distance of 50 meter from the benchmark. Theodolite is at a distance of 50 meter. Line of sight or line of collimation. Distance is given as 50 meter. The measured vertical angles from the horizontal at the staff readings 0.1 meter, 0.4 meter and 2.4 meter are found to be same. So angle is measured from the theodolite at two readings, that is one reading is at 0.4 meter and another reading is at 2.4 meter, and both those angles are same, which indicates one angle is at the depression and one angle is at the elevation. So the both the angles are same. So it is very clear one must be at the depression and one must be at the elevation. The depression will be, that is 0.4 meter and another thing is 2.4 meter. So this both the angles are same, that is theta. If these both the angles are same, This both the readings must be equidistant from the line of collimation. That is from this line of sight. From this line of sight, these both the points must be at the same distance from here. One and this one will be equal. So the total distance is 2.4 meter minus 0.4 meter. It is equal to 2 meter. So this will be equal to 1 meter and this will be equal to 1 meter. So this is equidistance. That's why we are getting the same angle. Taking the height of the instrument as 1.4 meter. So the height of instrument is given as 1.4 meter. The question is the RL of the theodolite station. So RL, we have to find this RL of theodolite station. So to find this RL is equal to, we already have this height of instrument. Height of instrument as 1.4 meter minus, sorry, if we find this line of sight, this line of sight, where is the height of this line of sight, and we can subtract that line of sight with the height of instrument so that we will get this RL. So if we can find the height of line of collimation, and if we can subtract this height of instrument, we will get the reduced level of this theodolite. So to find out this line of sight, we have to do nothing because we can find from this diagram itself. So look at the line of sight. So it is here. So this will be the line of, so this will be the height of line of collimation, that is line of sight. So this is equal to 0.4 meter plus 1 meter. So this is equal to 0.4 meter plus 1 meter and minus 1.4 meter. So this is from RL of benchmark. From RL of benchmark, it is 0.4 meter and 1 meter. So 100 plus 100 plus 0.4 meter plus 1 meter minus 1.4 meter. So it is equal to, we will get 1.4 minus 1.4. So finally we will get 100 meter because the RL of benchmark itself is 100 meter. So the line of sight elevation will be 100 plus 0.4 plus 1. So it is 100 and 1.4 and minus height of instrument, that is 1.4, and we will get RL is equal to 100 meter. So the answer is 100 meter. So that's it for today. Tomorrow let's see set 2 gate surveying problems from 2019. Thank you.